Okay, all right. So here we go, you guys. Today's date is 5/9/22. We want to talk about inverse variation graphs.
Girl.
So before I go into this, I'm going to give you a really good example, okay? So, I don't know, there used to be that old a show on TV about how they build a house in a week. Remember the name of that show was called? Remember they come in, they build a house in a week, and then they show somebody, and they go, whoa, there's your dream home, right?
Yeah.
So, here's my example. I have one house to build, okay? I could have 100 guys and gals help me build the house in a week. So lots of guys, short amount of time. Or I could have 5 guys build the house in 6 months. Small amount of guys, lots of days. So as either one of the two changes, the problem changes, right? So if I have lots and lots and lots of people, it takes a small amount of time. Or if I have very few people, it's just me building my house all by myself, it would take years, right?
Yeah.
So that's an inverse variation, right? Now direct variation is this. Direct variation is just the opposite. For a little kid, as I get older, I grow taller. They are directly linked. One gets bigger as the other gets bigger. Does that make sense? That's a direct variation. So let's go ahead. Direct variation is going to be y equals mx plus 0. Or the book likes y equals kx. That's the way the book likes it, but it's easier to take a look at this. So if you have a straight line, it's got to be straight, with a slope passing through zero, zero, it's direct variation, okay? An example of that would be y equals 3x. That's direct variation. Every year your plant grows by, or every week your plant grows by 3 inches. Right? Does that make sense? Okay, week 0 you have no growth. Week 1 you got 3 inches. Then another 3 inches. That's direct variation. As time progresses, the plant gets bigger. Okay? Plus, it's super important also we see the plus 0, it's invisible. It has to start at 0. Now inverse variation we just saw. If you have some x times y equals some number, and they like the value k again, or you can write as y equals k over x, that's inverse variation. As one gets bigger, the other gets smaller. Our example was x times y equals 24, or y equals 24 divided by x. Okay? That was our example. That's okay. Now the constant of variation is that value k. So in this example of the direct variation, k is 3. In this example of my inverse variation, k is 24. And I'll stop for a second. You guys can give me thumbs up, okay? Okay, and I'll slow down for a second, let you get caught up. Yeah, so either the graphs are going to look like this, or like this. Either my graphs are going to look something like this, or something like this. All right? My graphs are either going to look linear through the origin, direct variation, or they're going to look like this, inverse variation. Okay? I'm doing okay, aren't I? So here's the trick to doing these examples. So, solve for y. In all of these examples, if you can solve for y, then it's easy to tell which one it is, okay? So if we solve for y in all of these examples, it gets pretty easy to find out what it is, okay? All right, example 1. Am I going too fast? So which one is it? Is this going to be inverse, direct, or neither? Well, I'm pretty sure it's inverse because something times something equals negative 12. But if I divide, I'd have y equals negative 12 over x.
How can you solve for y if you don't know the x? Is that just it? Is that the most simplified it can be?
Yes.
Okay.
Yes. So it sure looks like this one here, doesn't it? Doesn't it look like this?
Yeah.
Which means then it's got to be inverse. It's got to be inverse variation. We know it's really multiples of negative 12. The graph would look like this, except for in the other two quadrants. This graph would look like this, except for the other two quadrants, okay? Example 2, well, let's go minus x minus x. I'd have y equals negative x plus 0.
That looks like direct variation.
It sure does, doesn't it? You guys agree? It looks like direct variation does. I'd say I agree with that, so I'd call that one direct variation. Totally agree, Cassidy. Number 3, it already says y equals. Might be backwards, right? It's already solved for y. I mean, I might rewrite as y equals 5 over x. I mean, same equation, right? That didn't trick me too badly, but which one is this one?
Inverse.
It is inverse. It is inverse. How am I doing, okay?
Yeah.
Example 4, to solve for y, I'm going to go minus 4 of x, subtract 4 equals 2y, right? I'll divide by 2, divide everything by 2, and I'll have a y equals 1/2 x minus 2. It's neither. I mean, it has a slope like this one, but it's supposed to go through 0. It has a slope, but it's supposed to go through 0, right? So this one's neither, because it doesn't start at the origin. So I'm going neither with this one, okay? All right. Number 5. Well, if I solve for y, I'm just going to multiply both sides by 4x. You get that? Times by 4x, times by 4x. I'll have y equals 48x. Which one is it? Nope. It is direct. Even though 48 seems like a big number, that's still a slope, isn't it? Still, so even though it's a big number, 48, so plus 0, it is direct. It's kind of like this. Every week, my plant grows by 48 millimeters. Grows by 48 millimeters. Every week, grows by 48, okay? So it's always moving up directly. As one goes up, the other goes up. Yeah, I'll slow down for you a second, okay? Yeah, I'm... Sure. Retta, you give me thumbs up when you're ready, okay?
Thumbs up.
Okay. Valeria, you guys ready? Sophia?
Yeah.
Okay, good. Turn the page. All right, now. Oh, you know, I don't know. I mean, I could try a graph. I could try graphing it to see what it looks like. Or maybe I can see the numbers. I mean, maybe you can see what it is. I don't know. But if I graph it, let's see what's going on if I graph this. I don't know. Let's see. I'm going to go maybe 2, 4, and I'm going to go 10, 20, 30. Let's see. It's going to look like 2, 4 is about there. 4 and 16 is about there. 6 and 36 is about there. 8 and 64 is about there. What do you think's going on? Doesn't look straight. It's not straight. Doesn't look like either one of these graphs, does it? Right? Doesn't look like either one of these graphs. So it's neither for sure. It's neither for sure. It happens to be y equals x. Happens to be y equals x squared. Do you recognize those numbers? Do you recognize that it's y equals x squared? So it's quadratic. This thing is quadratic.
Quadratic?
Yeah.
Okay.
Because quadratic is another name for an x squared graph, right? So it's neither. It's quadratic. It's an x squared. It's a parabola. All right? Didn't trick me.
Didn't trick me either.
Nope. Nope. How about number 7? Huh? Well, I'm gonna try and graph it. Let's see. I'm gonna have number 7. Let's just try graph. And I might have to go up to 50. Let's see. 10, 20, 30, 40, 50. Let's see. I have a 1 and a 5. A 5. 1, 2, 3, 4, 5. And a 1 of an 8 and a point. It's getting really small. Doesn't tell me much, does it? Doesn't tell me much. So then I'm like, I don't know what it is, but let me ask you guys an easy question. Easy question, honestly. What is 1 times 5? 1 times 5. What is 5 times 1? What is 8 times 0.625? I bet it's 5. What is 20 times 0.25? Bet it's 5. What's 50 times 0.1? Bet it's 5. I bet it's x times y equals 5. Hey, does that look familiar? Did we learn that? Which one's that one going to be? Inverse. Okay. All right. Number 8. Actually, number 8 is pretty easy. Okay, you ready? You know why it's easy? Tell me when you're ready for number 8. So there's a key word. There's a key word in number 8. X varies inversely with y. When I see that right off the bat, I'm like, wait a minute, I learned that equation. I think I learned that equation. X varies inversely with y. Oh yeah, I learned that equation here, didn't I? Right? I'm going to write x times y equals some value k. I'm just going to start there, okay? So yeah. So if x is 2, when y is negative 3, then we can find the value of k, can't we? So I plugged in 2 and negative 3, and so k, the constant is negative 6. Now I can rewrite my equation. So my equation should be this. Well, x times y equals negative 6. There's my equation, right? Now let's use my equation. So I got one last question in here. One last question. Find y when x is 12. All right. Let's use my equation. Let's plug in my 12. So let's have 12 times y equals negative 6, right? Divide by 12, right?
Why would you divide and not subtract?
X, what does xy mean? Yes. So y equals negative 6/12 or negative 1/2. You okay with that? That's all I have. And that homework is page 172. My notes say 172. 172, maybe 173? I don't know, I'll check it. Okay, 1 through 18 all, it's possible. I was in a really big hurry this morning when I came in. So who knows, right? Or no, I did this last night at like 8 o'clock last night when my wife wanted me to sit and have a glass of wine with her by the fire. But I thought of you guys first. You're welcome. And stop. I have a really good wife.